Now we will discuss about the role of starters in the case of DC motors. That is, why do we need starters in the case of DC motors? Then we will discuss about the different types of starters, that is 3-point starter, 4-point starter, which are used in DC, shunt and compound motors. So let's move further. Okay, first we will see why do we need a starter. Just imagine a condition where your motor is at rest. That is, motor at rest means the speed is 0, back EMF is 0. Now you are going to start the motor. Okay, so now what you do is you connect the motor directly to a supply. Okay, now just imagine that situation. Okay, what will be the current flowing through the motor when you start it? See, the back EMF equation is given by EB is equal to V minus IARA, where RA is the resistance of the armature, which will be very small. So initially the back EMF is 0 and the motor is at rest, right? So speed is also 0. So since the back EMF is 0, what will be the current that will flow through the motor? That current is given by V by RA. That means entire voltage will be applied to the motor and a heavy current will flow through the motor. That is, a heavy current will flow through the armature because the resistance of the armature is very less. Okay, so now what are the problems that can happen when this very high current flow through the armature? See, it can cause heavy sparking at the brushes. It can damage the armature winding because high current means a lot of heat will be generated and the armature winding can be damaged. Okay, then it can cause damage to the rotating part of the motor because since the current is very high, torque will be very high. So initially the motor will be stuck, quick acceleration will be there. This can also damage the rotating part of the motor, and again a large dip in the supply voltage. So these are some of the problems associated when you start a motor, okay, without using a starter, right? So what is the problem? The problem is initially the speed is 0, back EMF is 0, so there is nothing to oppose the applied voltage. Once the motor starts rotating, back EMF will be developed, okay, and this back EMF will oppose the voltage and slowly the current will increase. Okay, so sudden increase of current has to be avoided, which can damage the armature. So that is the reason why we are using a starter. Starter is nothing, it is an initial resistance which will be connected in series with the armature. So once the motor starts rotating, back EMF will be generated and the speed will be regulated. Okay, so once the back EMF is generated, it can oppose the voltage and the current can be controlled, right? So once the motor starts rotation, you don't need this resistance anymore. So you can remove this resistance entirely from the armature circuit. So it is actually temporarily you are connecting a resistance in series with the armature to control the current. Okay, once the back EMF is generated and when it starts regulating or controlling the current, you can remove this resistance. Okay, next we will move on to, okay, so already we discussed what will happen when suddenly you are connecting a motor to a supply line without using a starter. Okay, so how can you protect the motor? That is the question. So as I told, in order to protect this armature from damage, what you can do is connect a resistance. Initially connect a resistance in the armature circuit and slowly you reduce the resistance. That means initially a high resistance will be connected in series with the armature circuit so as to control the current. Okay, then what you do is slowly you will cut the resistance and finally you will remove the entire resistance from the circuit once the motor attains its regulated speed. Okay, then there a question can arise, right? Why don't we include this resistance? That is, what will happen if this additional resistance is left in the armature circuit? Why you have to remove it from the armature circuit? Why don't you insert it in the armature circuit permanently? That thing is that there will be a problem because additional resistance means when current flows through it, power loss, that is armature copper loss, I squared R loss or heat loss will happen, which can affect the efficiency of the motor, and also it can reduce the operating speed of the motor. So this is an additional resistance which is needed only during the starting time. After that you don't have to keep this resistance. Still, if you keep the resistance in the armature circuit, it will affect the efficiency of the motor. Okay, so then which are the this is actually the circuit diagram which will explain this more clearly. So this is a shunt motor. You can see the armature here and shunt field winding here. RSH resistance of the shunt field winding, RA resistance of the armature. IA is the current flowing through the armature, IL is the line current, and this is the terminal voltage V. ISH is the current flowing through the shunt field winding. Now this is what is called external resistance. See here. Now this point, that is which is connected to the armature terminal, you can connect it here. When you connect it here, what will happen? The current from the supply, it will come here and it will cover the entire resistance. See, it will flow through the entire resistance and then it will flow through the armature. That means the entire resistance is included initially. That means current will be less. Now, next suppose if you connect at this point, what happens? The current after reaching here, it will follow this path like this. So that means only this much resistance is connected, right? Now again, suppose just imagine that you are connecting at this point, the rheostat position is like this, then the current will reach here and it will not flow through the starting resistance, it will flow directly to the armature terminals. So this condition is called the on condition of the motor. That is, once the motor develops back EMF and attains the regulating speed or rated speed, you can remove this resistance. That means directly the current will flow through the armature winding. You don't need any additional resistance because now back EMF can handle the applied voltage. It will oppose applied voltage, and as I told, it can act as a governor and it will control the speed of the motor. Okay. Now talking about the types of motors. Which are the types of motors which are the types of motors where this you need starters? So there are mainly two types of starters, that is 3-point starter and 4-point starter. So in the case of DC shunt and DC compound motors, we can use these types of starters, 3-point starter, 4-point starter. Okay. Now we will go into the details of the 3-point starter. So this is the circuit diagram of a 3-point starter. Now I will explain each part of this 3-point starter. Now first of all, why do we call this as a 3-point starter? Here you can see there are 3 terminals, L, F, A. Okay. Now first we will see what is this L. L denotes line. Okay. Here you can see the DC supply and here is a switch. So when the switch is closed, what will happen? Current will flow. And then the current reaches here, the line terminal L. Okay. See, this is the flow. It reaches the line terminal L. And from here you can see it flows through a coil. Here you can see a coil here. See, there is a coil here. And from this coil, it will reach this spring. You can see a spring here. And then it will flow through this. You call this a starter arm. Okay. This is the flow. Okay. Okay. Now we will see the other part, that is the F, the terminal F. What is this F? What is this A? We will see. Okay. Now if you see the terminal F, it is connected to, see here, it is connected to another coil. See here, it is connected to another coil, and the other end of the coil is connected to something called a brass arc. This is the brass arc. See, got it? That is the F, the terminal F, which is connected to the shunt field winding, or you can say that one end of the shunt field winding is connected through a coil to the brass arc. Okay, so that is about the terminal F. Now we will see about the terminal A, that is armature. That is one end of the armature is connected to the terminal A, and this is connected to where? You can see here. This is connected to the end of a starting resistance R. Okay, so this is the end of the starting resistance R. So this is called a 3-point starter because we have got 3 points here, L, F and A. Okay, now we will go through the starting resistance. Now here you can see the starting resistance. See here, this is the starting resistance. And you can see that there are how many studs are there? That is stud 1, 2, 3, 4, 5, 6. Okay. Now this position, that is, this is the starting arm. As I told before, this is a starting arm. and you can see here a spring here. So what is the function of the spring? The spring action will keep the starter arm in the off position. So this is the off position. Now from this position, this starter arm can be rotated in the clockwise direction. Like this, it can be rotated. So the starter arm, this particular point, it can be connected to either the stud 1, stud 2, stud 3, stud 4, stud 5 or stud 6. Okay, so there are different positions for this starting resistance. Initially, we will be connecting to the stud 1 so that the entire resistance will be included in the circuit. Afterwards, you will slowly move the starter arm from position 1, 2, 3 like that. Slowly you are reducing the resistance. Okay, so initially high resistance, then slowly you will reduce the resistance, and finally you will reach this point. That is, the starter arm will be connected like this. So can you see here one iron piece kept here? Okay, so when it reaches this point, that is, you call this at on position, when the starter arm is in this particular position, you can see here the soft iron piece. So that will come here. Okay, now as I told before, here there is one coil, right? You call this as holding coil or no volt release coil. Okay, and again here also there is one coil, and this coil you call it as overload release coil. So two coils are there. Okay, so when the current is flowing through the coil, you can see that these two coils are wound over magnet, right? Here also there is a magnet, and here also there is a magnet. So when the current flow through the windings, this magnet will become what? It will become an electromagnet. Okay, so when the starter arm comes in this particular position, this iron piece will be attracted by whom? By this magnet, because now it is acting as an electromagnet. So what will happen? This electromagnet will hold this iron piece so that against the action of the spring. Okay, so that means the soft iron piece will be attached to this electromagnet at this on position. And in this position, if you see what will be the current flow in this on position, the current will come like this. It will flow through L. It will reach this coil. Then it will reach this spring. And from the spring, it will follow this path. See, it will follow this path. See here. So it is not flowing through any of the armature resistance, right? And from here, one part will flow through the A terminal to the armature. And the second part, what will happen to the second path? That is, there is something called a brass arc, no? So brass arc is also connected. So the current flowing through the brass arc, it will flow through this coil, that is no volt release coil, and then it will flow through the shunt field. See, so this is the flow. Now from here, this current will flow back through the switch to the negative terminal. Okay, so in the on position, what will happen is that the soft iron piece will be held very strong by this electromagnet, and in starting resistance will be completely removed from the armature circuit. Okay, and what will be the current flow? The line current coming to the starter arm. Okay, one part will flow through to the armature terminals, the other part will flow through the holding coil to the shunt field. Okay, so now one thing you have to understand is that here the current which is flowing through the shunt field, it is the same as the current which is flowing through the holding coil. That means both of them are connected in series. Okay, now if you consider the line current, the entire line current is flowing through the overload release coil. So these are the important parts of this 3-point starter. Okay, now this is the same thing which is explained here. That is, 3-point starter has got 3 terminals, L, F and A. Okay, now the starting resistance, it is divided into several sections. That is why it told different studs are there, studs 1, 2, 3, 4, 5, 6, etc. Okay, now there is another thing called a brass arc. Okay, and which is the connection is made to the shunt field. So from the brass arc, you can see here, this is the brass arc, and from the brass arc, it is connected to through the coil to the shunt field. Okay, okay. Now then, the last stud of the starting resistance, is connected to the terminal A. That is the 0.6. See here, the 0.6 is connected to the armature. Okay, the last resistance. Last stud of the starting resistance. Now the positive supply line is connected to the line terminal L through the main switch. That is also shown here. See the positive terminal, it is connected through the switch to the L. Okay. Now I think I will clear this so that it will be easy to understand. So the different parts, the coils, that is no volt release coil and overload release coil, that is it has the major role in the case of the starter. Okay, so both these coils, no volt release coil and overload release coil, both are wound over a magnet. That is, when current passes through the coil, then only the magnet will act as an electromagnet. So when it acts as an electromagnet means it has got that magnetic force, it can exert that magnetic force, and it is due to this force that it is able to hold the iron piece. So when does it hold the iron piece? When the starter arm is in the on position. So initially the starter arm is in the off position, and then the spring will keep that in that off position. So in order to bring that starter arm to the on position, some force is needed against the spring, right? And for that we are using the magnet. Okay, so I think now it is clear. Okay, now we'll explain the parts one more time. Okay, so now here, okay, now from the line terminal L, supply is connected to the starter arm through the overload release coil. What is the meaning of that? From the line, see here, this is the line terminal L. From here, it is connected to where? Through the, this is the overload release coil. Through the overload release coil, it is connected to the starter arm. Okay. So the entire line current will flow through the overload release coil. Now you can see that a spiral spring, what is the purpose of the spring? That is to bring the starter arm to the off position. So which is the off position? This is the off position. So in order to bring this starter arm to the off position, we are using this spring. This is the spring. Okay. Okay. Now you can see that a soft iron piece is attached to the starter arm. That already I told you what is the purpose of that. Here you can see the soft iron piece. So when the starter arm reaches this particular position, this soft iron piece will be, it will come here and this will be attracted by this magnet. So that force will be there, no? So that it will be kept in that on position. Okay, so this is about the important parts of the 3-point starter. Now we will move on to the working of this 3-point starter. Okay, so first we will see that it is in the off position. So first it is in the off position. Now then slowly first we will bring it to this particular position. So the current from the supply, it will flow through the switch. It will reach the point L. Okay, it will reach the point L, and from it will flow through the overload release coil, reaches the starter arm, flows through the starter arm, reaches the point 1. Okay, and from the 1 it will flow through the entire resistance, and then it will flow to the armature. Also the current from this point 1, it will flow through the brass arc, then it will flow through this particular coil which you call it as holding coil, then it will flow through the shunt field. So that means shunt field current and the current which is flowing through the holding coil are the same. They are connected in series. And also you can see that there are another end, that is one end of the holding coil you can see here. See here. And another end is taken here. The purpose of this I will explain later. Why these two coils, two ends are kept like this, I will explain later. Okay. Now, the motor is started by switching on the DC supply by closing the main switch and keeping the starter in the off position. So initially the starter is in the off position. Then what you will do? Then you will turn the starter arm clockwise. So when it comes in contact with the first stud, whole starting resistance is inserted in series with the armature. That is very important. Initially, when you connect it to this particular point, this particular stud means the current will flow through the entire resistance. Okay, that is explained by this point. Then you can see that the field winding is connected directly across the supply, across the brass arc. This already I explained. That is the current which is flowing through the field winding, and the no volt release coil is the same. They are connected in series. Okay. Now as the starter is moved, it will slowly cut the resistance. Okay. Finally, when it reaches on position, what will happen? No more resistance in the circuit, and it is held against the action of the spring by the force of attraction between which all coil, which that is the magnet, and the soft iron keeper, that is in the on position. That is, when it reaches this particular position, that is on position, this magnet will exert a force on the soft iron piece and it will be held there. Okay, so this is about the working of the 3-point starter. So once the motor starts gaining speed and back EMF, that is in the on position, the starter is no more used. Okay, now let us discuss about the very important part of this 3-point starter, which you call it as no volt release coil. So what is the purpose of using this no volt release coil? Which is a no volt release coil? This is a no volt release coil. Okay, just imagine that suddenly there is an interruption in the power supply. So suddenly if there is an interruption in the power supply, what will happen to the motor? That is, suddenly the power went, and after some time again the power again came back. So what will happen to the motor? How will you ensure the safety of the motor? That is a question. So the sudden power supply interruption means there won't be any current flow, right? So if there is no current flow means there won't be any current through this particular coil. Okay, so if there is no current through this particular coil means this magnet will no longer be an electromagnet. So it won't be able to attract this iron piece here. So what will happen? That spring, it will come into action. So the spring will take this from on position to off position. Okay, that will happen in the case of power interruption. Is it good or bad? It is good, because again when the power comes and the motor starts, what it has to go to the original position. That is, again you have to start from the beginning. Again you will put it in stud 1, stud 2, stud 3, like that, in order to control the current. Just imagine during the power interruption, if the starter arm doesn't go back to the off position but it still remains in the on position, just imagine, is there any resistance in the circuit now? No resistance is there. Directly the current will go through the armature terminals. It won't go through this resistance. Okay, so that is one of the purpose of using this no volt release coil. Okay, so it is actually helps to protect the motor. That is, when the supply is cut off, the starter arm reaches the off position automatically as soon as the supply is cut. When the supply is cut off, it will automatically go to the off position. So again it will start when it comes to the on position. How? That is, slowly you will cut the resistance. Okay, so what happens is that when the supply fails, the electromagnet demagnetizes. That is very important, because there is no longer any current flow through the no volt release coil. So the electromagnet demagnetizes. So it will release the starter arm and it will go off to the off position. So again when the supply comes, what will happen? Again you have to cut the resistance by controlling the current. You will repeat the same procedure. There is one more case, that is, what will happen? There is one case in the case of DC shunt motor, that is, if there is any open shunt field, what will happen? Open shunt field means there is open circuit. So open circuit means current, what will happen to the current? So in the case of open shunt field, the flux will be zero. Flux will be zero means current speed will be very high. So that condition has to be avoided, right? So we will see how this no volt release coil helps to avoid this motor from operating in open shunt field condition. If you see here, the current which is flowing through the no volt release coil and the shunt field are the same because they are connected in series. So if the flux becomes zero here, there won't be any current here, right? If flux is zero means current will not be there. So if there is no current through the shunt field means there is no current through the no volt release coil also. So if no volt release coil, there is no current means this magnet will demagnetize and the motor starter will go back to the off position. That means motor will be, so that is it is going back to the off position. Okay, starter arm will go back to the off position. Okay, so this is also another protective feature. That is, it will avoid the motor from operating under the condition of flux zero. Flux is zero, speed can become dangerously high. Now, due to this property, what happens? It will go back to the off position. Okay, the starter arm will go back to the off position. Okay. So, it provides protection to the motor, no volt release coil. Now, we will discuss about overload release coil. So, what is this overload release coil? Overload release coil is connected here. So as I told before, when you close the switch, the full line current will flow through this overload release coil. Just imagine if the current flowing is very high. The current flowing through this coil is very high. What will happen is that it will pull this, you can see something like a lever. It will pull this lever up so that these 2 points will be shorted. See? So when a high current, in case of very high current, this particular coil, it will develop when a high current is flowing through this coil, which you call it as overload release coil. The magnetic pull of this electromagnet will pull this lever up, okay, and these 2 points will be shorted. Now what are these 2 points? One end is the, see here, this coil. This is one end of the holding coil or no volt release coil, and this is another end of the holding coil. So how does it affect? When it is shorted, what will happen? We will see. That is a current which is reaching the brass, this point. You can see this point, no? The current which is reaching this point, now it will not flow through the no volt release coil. Because current always follows a path of least resistance. Now there is a short circuit there. So what current will flow? Current will do after reaching this brass point, instead of flowing through the coil, it will flow from here, it will flow directly to this point, this short circuited point, and see, and it will not flow through the coil, it will flow like this. Got it? This is because of the short circuit. I will show that one more time. That is, what is the purpose of using this overload release coil? That is how it will help in avoiding that problem. We will see. I will explain it one more time. Okay. Now just imagine that the current which is flowing through this coil is very high. That means it will pull up this lever up. So when it pull the lever up, these 2 points will be shorted. So just imagine the motor in this the starter is in this on position, which means the motor is operating in the on position. So when the starter arm is in the on position, the motor is having its normal speed. So the current after coming here, see the current is coming here, it will not flow through the coil. It will follow this path. You see the path? This will be the path of the current. See, it is not flowing through the coil. So if no current is flowing through this coil, means this will not act as an electromagnet. So no longer can it hold the soft iron piece. So if it cannot hold the soft iron piece, what will happen? This particular spring, what it will do? It will pull back the starter arm to the off position. Okay, so that means that is starter. That is, it will go back to the original position. That means the motor will turn off. Okay. So in the case of overload condition as well as in the case of power interruption, the starter arm will help to turn the motor off. So when the power comes or when the overload condition is clear, then again you will start from the very beginning. Okay, that is, you will first include the entire resistance in the armature circuit. So this is another protective feature of this starters, that is overload release coil. Okay, that is, it being short circuited, it will demagnetize and release the starting arm. That is, when the no volt release coil, okay, if the that is overload release coil, what actually it does is it pulls the lever, right? It pulls the lever up, in short circuits the no volt release coil. So when the no volt release coil, when there is no current flow through the no volt release coil, the magnet will no longer act as an electromagnet, so it can no longer attract the iron piece, and so the starter arm will go back to the off position. Okay, so thereby ensuring the protection of the DC motor. Now, what are the disadvantages of the 3-point starter? There are some disadvantages because, as I told you, the current which is flowing through the shunt field is the same as the current flowing through the no volt release coil because both are connected in series. Okay, we will just see here. See, the current which is flowing through this shunt field and the current which is flowing through these coils, both are the same. Now just imagine if due to some reason when you are adjusting the resistance in the field circuit, if the current ISH becomes very small, what will happen? The current through the no volt release coil will also become very small, right? Here the current will become very small. So the electromagnet will not be able to develop that much force to attract the soft iron piece. So due to unnecessary reasons, okay, what will happen? This spring will again pull the starter arm back to the off position. So it is not any emergency condition, but it is due to some adjustment in the field circuit. So this is a disadvantage. Unnecessary, the motor will turn off depending on the current in the shunt field winding. Okay. So that is actually a disadvantages of this 3-point starter. That is, if the holding coil or no volt release coil is no longer able to create sufficient electromagnetic pull to overcome the spring action, the starter arm will fall back to the off position. Again, the motor will turn off. Actually, it is not a condition of power interruption or overload. It is because of some adjustment in the field circuit. So this is because the current flowing through the shunt field winding and the no volt release coil is the same. So why don't we make it independent? Okay. So that is done in the case of a 4-point starter. That is only difference in the case of a 4-point starter. So here you can see the brass. See the brass, one end of the brass, see, it is connected directly to the terminal F, and to the shunt field winding. And there is another contact from here, which is, see here, there is another path from the same brass which you are giving through this, you are connecting it to the coil. Which coil? No volt release coil, and then it is connected to another external resistance. See, this is only difference here. And as before, you can see there are two ends of the coils are taken like this, which is needed in the case of overload release. So the only difference you can see is that the current which reaches the brass, okay, from the two paths are there. One path, it takes it to the shunt field, okay, and the other path is given to the coil. That is no volt release coil. That means the current flowing through the shunt field winding will not affect the current flowing through the no volt release coil. They are made independent. So that unnecessary turn off of the DC motor will not happen due to the starter arm going back to the off position. So you understood what is the disadvantage of the 3-point starter? That is, in the 3-point starter, the problem is that the current flowing through the shunt field winding and the no volt release coil are the same. So if there is any adjustment done in the shunt field, that is by adjusting the resistance or something, if the current becomes very small, then the starter arm will be pulled back to the off position. So in order to avoid that, what you are doing is the current flowing through the shunt field winding and the no volt release coil is made independent by providing two independent paths. Okay, so that is done in the case of 4-point starter. So I hope this is about the starters. I hope it's clear.